As you saw, we just obtained one of the most important project deliverable, the project schedule. We now know when are things on the project going to happen. We are now off to knowing how much does the project need in terms of the resources like people, equipment, etc., or how much money is required to get the project done, or even to what extent do we want the quality of the project to be satisfying to the stakeholders, and lastly, how much risk can the project take or avoid to get the project delivered. These are all the quantitative items that we will discuss now. As you see here, the cost, quality, resource, and risk management knowledge areas are the areas that we will be discussing that belong to the how much or the how many portion of the pie. And this is where you will be doing most of the math that may be involved on the project. Very similar to the schedule management knowledge area is the cost management knowledge area. As we saw earlier, we obtained the project schedule by breaking down the WBS into individual activities and determining the activity durations to each of those activities, which then could be rolled up to obtain the final project schedule. On similar lines, we will determine the overall project budget using the inputs we have so far. And as you see here, the scope baseline and the project schedule obtained from the schedule management knowledge area are the primary inputs that we will use to determine the overall project budget. This will consist of two processes, the first of which is estimate costs. This is very similar to estimating the activity durations that we saw earlier, where we estimate the amount of money that is needed to perform each of these activities based on the information we have from the past projects or from the estimates we may receive on the current project from the various estimation methods. As the estimate cost process produces the activity cost estimates that will have the amount of money that is needed to work on each of these individual activities at those specific points in time that were determined through the schedule management process. Taking the pyramids example and working on one specific portion of the scope, which is the exteriors of the pyramids, we can now estimate the cost of working on each of these activities as shown here. As you see here, the cost on working on each of these work packages, on building the stone blocks and working on the mortar, we can associate a certain cost to the activities of excavation, cutting, and transporting the stones, and also the excavation of mortar and transporting it to the site. These, as you see, are mapped onto the same schedule network diagrams so that we could sum up the cost on each of these paths. The final process in the cost management knowledge area is the determine budget process that will aggregate the costs from each of the activities that we determined in the previous process of estimation, and by summing up all of them to levels that we want on the project, we could determine the budgets that are necessary to work on the project. Sometimes the aggregation of costs are done to a higher level on the work breakdown structure to make it meaningful for the organization's accounting systems to handle the funds. These are called control accounts, which makes it easier to monitor and control the project budget on smaller components of the project, broken down by various departmental activities or other scope of the project that are independent of one another. Hence, the important project deliverable we get from the cost management knowledge area is the project budget, which is an important determination to know how much money is going to be spent on the project. At this point, we have the project budget ready, which means we now know how much money does it take to work on this project and build the final product or service. Similar to the previous steps pertaining to estimating the amount of effort on each activity and the amount of money needed to be spent on each activity, we can now determine the number of resources on each activities as well. This is done in the resource management knowledge area. The first process in the resource management knowledge area is the estimate activity resources, which is a process that is used to estimate the number of resources we need to put on each of these activities to comfortably deliver them in the amount of time that we determined earlier and the amount of money that will be spent. Hence, using the same inputs that we obtained from the previous processes, we could now estimate the number of resources that may be needed to work on each of the activities on the project. The output that we get from this process is the resource requirements document and the resource breakdown structure, which is another hierarchical structure that shows you the resource assignments on each of the activities on the project. Sometimes it is the assignment of resources on the activities that may determine the costs that will be incurred on each of the activities and hence may be needed to be done before the estimation of costs on the activities. Using the same example in the pyramids project, as you see here, the determination of the number of resources is done through the estimation techniques that are available on the project based on the experiences from the previous project and the organizational process assets. The resource assignments on each of these activities are illustrated to show you vaguely the number of resources that may be needed on each of them. As you can see here, the cutting of the stone may need more number of resources relative to the excavation process and transporting it, or the blocks of stone that make up the pyramid. Until this point, we have now quantified the amount of money that is needed to be spent on the project to execute the project and the number of resources in terms of the people with the relevant skill sets to work on the project are determined here in this knowledge area. At this point in time, we now know how much project resources are needed to deliver on the project objectives, which means we now have a good understanding of who are all the project team members who will work on the project. It is not enough to simply deliver a project in its defined scope boundaries under the agreed budget and in the time frame decided. Although meeting those constraints are necessary to deliver a project successfully, the product, service, or result you plan to deliver must satisfy the needs of the stakeholders as they expect to get. This is where we will discuss the quality management knowledge area. First, let's discuss what is quality. Quality is the measure of to what extent you are satisfying the customer or the sponsor by meeting their requirements on the project. Very similar to product and project scope, there is product quality and project quality that needs to be defined, planned, and controlled. Quality of the delivered product is not difficult to understand. It is simply the final product that the customer can decide if it meets their expectations or not based on what was initially agreed at the start of the project. These are product quality norms that are to be followed to deliver the right product or service. In addition, there is the project quality. It is a measure of how efficiently you're executing the project or how much did you sway from the original baseline plan. To make this determination, you need some kind of metrics that can be used to measure the performance of the project. For example, the percentage of number of actual tasks completed versus the planned, how much delay is it in the project beyond the planned schedule, or even the cost overrun, you may be above the planned budget. These are all the quality metrics that are important to determine the health of the project. While quantifying the number of defects encountered and resolved during the testing phases on projects that involve product testing come under product quality, whereas variations from the baseline project parameters like the scope, cost, and time come under project quality. From the organizational process assets, objective comparisons can be made from other historical projects done in the past. This is determined in the plan quality process with the inputs of all three baselines on scope, schedule, and cost, and more importantly, the stakeholder register. If you recall, the stakeholder register contained the expectations of each stakeholder that were captured in the initiating phase of the project. Since quality is all about satisfying them, the stakeholder register becomes an important input to this process. The output you get are the quality metrics that are quantifiable measurements through which you can determine the health of the project. These metrics become the underpinning of project communication to senior management and project sponsors by summarizing the overall health of the project at a higher level, probably as traffic light statuses in red, yellow, and green color coding, or some other easier form of summarization techniques to represent the overall project status. The tools to determine the product quality is testing, whereas the tools to determine the project quality is benchmarking. Testing is ensuring your product or service is doing what it is supposed to do when it is finally going to be delivered. Example, in the case of pyramids, imagine the main door to the entry to the pyramids is jammed on its first use. Testing to ensure the door to the passageway opens when needed is ensuring there is enough product quality built in the project. Benchmarking is a process of comparing previous similar activities to the current project activities to provide a standard to measure project performance. This comparison will also help you derive ideas for quality improvements on the current project. By finishing the plan quality process, we now have the quality metrics available at this point, which will help us in the future to control the project, where it actually moves in the execution phase. We will now be discussing an important concept in project management called as risk management. So far, you did your best in capturing the scope, schedule, and cost on the project. And among other things, you also assigned people, planned for quality, and ensured that the project is on track for a successful completion. But just like the world we live in, projects operate in a lot of uncertainties. Just like you don't know if it is going to rain a month from now or not, you don't know what will happen far into the project. To explain the concept of risks, here is an illustration where you, the PM, where you're required to navigate your way through this landscape, which contains a lot of holes in the ground, and those holes present varying degrees of danger to you should you fall in them. Your task is to safely find your way by avoiding the danger of falling in these holes and reach towards the end. The idea here is you're taking your project all the way to the end by navigating it through various uncertainties that you will encounter during the course of the project. Risks are uncertain events that matter to the project, and should they occur, have an effect on the objectives of the project. Note the words uncertainties that matter. Not all uncertainties are risks to your project. Example, whether it's going to rain or not tomorrow has nothing to do with if you will go live with your software development project. However, this may be important to know if you are in a construction project. All uncertainties that matter should be considered as risks to the project. The uncertainty of falling in one of these holes is a risk that you have to face in your effort to meet the challenge. As you see here, the first hole is a smaller risk of you falling into that is not too deep and that contains nothing dangerous in it. The second hole, though, is a bigger risk in comparison to the previous one because not only is the hole larger in diameter, but also puts you with the danger of getting harmed by a nail that is at its bottom. In the third hole, though, the diameter of the hole is smaller than in the previous one, which means that you could easily cross it. However, should you fall into it, you run the risk of being bitten by a poisonous snake that is curled up at its bottom. Moving to the last hole, you can clearly see that not only is the diameter of this hole too big for you to easily jump over, but should you fall into it, you run a greater chance of putting yourself in life-threatening situation due to the big, hungry bear that waits at its bottom. Hence, what we have done here is illustrated the concept of the various degrees of risks that you may face on a project based on two dimensions that we will use to quantify risks and measure them for our analysis.